the shortest side is exactly half the longest side. We all good? A for the day. Does anybody remember? My guess is most people won't remember this. Does anybody remember what this length is? You just have to attach the root of 3 to it. That's something that was shown to you during geometry. If you want us to, we could go ahead and show that using the Pythagorean Theorem, but it always just works out where you attach the square root of 3. Always. Good? Okay. So what if I change this? What if, say, this side over here was 7? What would this side be? 14. What would this side be? 7 roots of 3. And that is always the case. 45, 45, 90. Does anybody know what is true about a 45, 45, 90? Good, it's a right triangle. What else? Two sides are the same. It's called an isosceles right triangle. These two are the same. So therefore, if this has a measure of 6, what does this side measure? It measures 6. Does anybody know what we do to get the hypotenuse? For a 45, 45, 90, it's times the root of 2. We could show you using the Pythagorean Theorem. Would you like me to show you? Okay. So, that piece we know. Let's try another. Suppose that this had a length of 4. What would this length be? 4, what would this length be? Look at how smart you are. Now, we're not done. I got to try to make sure that you understand this completely. Suppose that this had a length of 7 roots of 2. What would this length be? And this would be good. So, now you're like, okay, this is easy. I know what I'm doing. Well, what if we did this? What if this was 5? So, to get from here to here, you multiply by the square root of 2, right? So, to get from here to here, you divide. So, it'd be 5 over the square root of 2. Now, can you leave the square root of 2 in the denominator? So what do you do to the top and bottom? Multiply top and bottom by the square root of 2, and you get 5 roots of 2 over 2. 5 roots of 2 over 2. So that's a piece that you want to remember as well. Awesome. Sophie says she absolutely hates it. So, okay, so let's try the 30, 60, 90 over here. The only difference here is it's just rotated upright. Suppose this has a length of 24. Can somebody tell me what this length is? 12. It's exactly half of the longest length. What do we multiply by to get this side? 12 roots of 3. Excellent. You now have the geometry that you need to carry out what we want to do right here. I'm sorry, which is we want to be able to determine those points. Don't flip it over. So here we go. We have pi over 4. First of all, you want to find the terminal points. You want to find the coordinate, the xy coordinate for pi over 4. That's our goal. The first step is to turn it into a degree so you know what kind of angle you're working with. Pi over 4, does anybody know the angle for pi over 4, the degrees? Okay, and so we can convert this. The more you work to kind of commit them to memory, the faster you're going to be without a doubt. I multiply by 180 over pi. What happens? Pi's cancel. What's 180 divided by 4? 45 degrees. So I'm trying to find the terminal point or the coordinate at 45 degrees. So I'm trying to find that spot right there. And what we do in order to find that spot is we use our geometry of our special right triangles. And the geometry of our special right triangle says that this is a 45, 45, 90 triangle. Can anybody remember what we said on the previous page can anybody remember what we said was the length of our radius? What's the length of our radius? Yeah, so that coordinate was 1, 0, so it means the radius has a length of 1, right? So this will always be the case. The length from here to here is always 1. Every time. You don't ever have to change that, okay? So with your 45, 45, 90, if you're given the hypotenuse, what did you do in order to get the other side? We divided by the square root of 2. So in order to go from here to here, you have to divide by the square root of 2. Can you leave the square root of 2 in the denominator? So what do? Top and bottom by? Good. So what do you get? Root of 2 on the top and 2 on the bottom. So that is this dimension right here. What is this dimension? How come? Very good. So once we've done that difficult work, then that becomes very simple. So we now have the xy coordinate. We know that we are over root of 2 over 2, and we are up root of 2 over 2. So you can flip back to your other side right over here, and where it says 45, you could write in the square root of 2 over 2, square root of 2 over 2. A lot more spaces to fill in, isn't there? Fortunately, you're a very smart class, and I think you kind of did the harder of the 3 problems right there. Let's try letter B, and then C, and then D. This is a 2-day lesson. Tomorrow we'll be practicing, giving you time to work on your homework. T is equal to, or theta is equal to 4 pi over 3. If you see T, we say it's the same as theta. It's just a variable. How do I convert that to degrees? Does anybody know the degree measure for 4 pi over 3? 240, yes. So as you convert, you take 180 and divide it by pi. The pi's cancel, and 180 divided by 3 is 60, and 60 times 4 is 240. So yes, 240 degrees. Which quadrant does 240 place me in? The third quadrant. So I go all the way around until I get to about like right here, right? Now, this is where people start to struggle with this. You always draw your triangle against the x-axis. Don't draw it against the y-axis. Always draw it against the x-axis. How many degrees past 180 did I go to get to 240? 60 degrees past. So this is a 60-degree angle right there. So what special right triangle do I have? A 60, 30, 90. What is always the length of the radius? 1. On a 60, 30, 90, how do you go from the long side? How do you get to the short side? How does the short side compare to the longest side? Divide in half. So it's going to be 1/2. Once you know the shortest side, what do you do to get the other side? You multiply by the square root of 3. So I'll show this once. The square root of 3 times 1/2. You end up with the square root of 3 on top, and you end up with 2 on the bottom. So I need to find this coordinate right here. It has an xy value. X is the horizontal. So what's the horizontal going to be? 1/2. But if it's in the third quadrant, it's going to be negative 1/2. And then what's the y value? Negative root of 3 over 2. If I'm in the third quadrant, both the values will be negative. So I'm going to go back to this page, and I'm going to mark that down. We have 240 degrees, which is the same as 4 pi over 3. 240 degrees is the same as 4 pi over 3. So the location of that coordinate we just said was negative 1/2 and negative root of 3 over 2. We do 2 more. What's different about the next one? It is negative. So that means instead of rotating counterclockwise, I rotate clockwise. Let's convert it from radians into degrees. I multiply by 180 and I divide by pi. What happens to the pi's? They cancel. 180 divided by 6. 30 times 5. So negative 150 degrees. Which quadrant does negative 150 place you in? The second quadrant. No. 150 degrees would place me in the second quadrant right there. But since we're going negative, yep, we'll be like right over here, right? That's my angle. I always draw the triangle against the x-axis. So if this is 150 degrees to get back here, how many degrees are left over? 30. What kind of special triangle do I have? A 30, 60, 90. What is always the length of the radius? It is 1. So then the shortest side, Josh, is half. And what do you do to the longer side then? You multiply the short side by, and you get square root of 3 over 2. Excellent. So I need that coordinate right there. What is the horizontal distance? Yep, negative root of 3 over 2. And what is the vertical distance? Negative 1/2. I'm going to put that over on this side. So negative root of 3 over 2, negative 1/2. We said that was, so negative 150 degrees would be the same as 210 degrees, wouldn't it be? Same spot. And we'll mark that as 7 pi over 6. Good morning, sir.
Good morning.
How are you today?
Good. Morning, Ron. Here. Good morning.
Thank you.
Probably up now.
Okay, last example. Flip back here. Negative pi over 2. Again, it's negative, but as you see pi over 2, how many degrees is pi over 2? 90. Good. Starting to pick up on those angle measures is going to help you be a lot quicker and more efficient as you work through some of these problems. We have negative 90 degrees. So, Josh, could you tell me when I rotated negative 90 degrees? Right there? Now, for a lot of people, when they do this, they automatically try to start to draw a triangle. Don't. This is the easiest problem we've seen yet. The reason why is you are trying to find the coordinate for where it crosses that circle. You don't have to draw a triangle, do you? What's that coordinate? 0, -1. You're done. If you end up on one of the axes, don't draw a triangle, just name the coordinate. That's all you have to do. So if we flip back to this spot here, notice that you end up at a location of 270 degrees, which is 3 pi over 2. Good work. Flip to your homework.